I'm Ryan, this is Charles, and we're going to talk a little bit about what we worked on this summer for the Riggs Fellowship. So the Riggs Fellowship is an endowed engineering fellowship here at Harvey Mudd. And what we do is we have a group of rising juniors and seniors here at Mudd, advised by Professor Gokley, and we basically come into small local companies and we help them out with their manufacturing operations. So this is really cool because what we're able to do is take Prof. Gokley's E182, Manufacturing Planning and Execution, and we're able to immediately apply that knowledge to real-world situations. It usually has a very beneficial impact, not only for us as engineers, we're able to apply our skills and do a lot of real-world problem solving and learning, but it also has a really beneficial impact on the companies that we're working with.
All right, to talk a little bit more about the parameters of our projects, we worked with 2 partner companies over the course of 10 weeks this past summer. That's an equivalent of 5 weeks of concentrated work at each company. And by working with these 2 partners, we were able to get experience with both high-level systems changes to company structure, as well as low-level implementation on the factory floor. And at the end of both these projects, we were able to realize some pretty significant cost savings and improvements. So with one of our partners, we ended up saving $83,000 annually in material handling costs, and then another partner, we realized a 156% increase in throughput. So I'll talk about how we got to those results. So one of our partners this past summer was a art supply manufacturer in City of Industry named Laguna Clay. And so when we got there on the first day, this is what we saw. And this was our first experience in taking manufacturing engineering out of the case study in the classroom and into the real world. When you get a case study, as I'm sure you all know, you get all the information presented to you in a fairly neat format. But that's not what you get when you get on the manufacturing floor. And you have to look at all of this, see what information is relevant, what can go, what can stay, what is waste, and what's value added, and turn those into improvements. So go to the next slide. The challenges that we identified with our partner's operations were kind of this pernicious triad of high batch size, long lead time, and inflated cycle time. And so we applied the kind of lean manufacturing fundamentals that we learned from Professor Gokley to move these operations towards single piece flow. And when you're doing a case study in the classroom, single piece flow is as easy as writing, you should move to single piece flow. But when you implement it on the factory floor, you need to develop the entire infrastructure to support that. So what we did was we developed a improved production scheduling system, improved assembly area layout, and rebuilt every workstation on this assembly line from scratch. And by doing that, we were able to realize a 62% reduction in cycle time across all of these processes, which resulted in a more than 150% increase in throughput in this facility, all with an 86% decrease in working process. We were able to realize the impactful results for this company's operations.
So I'm going to talk a little bit about our job at Mission Rubber, which was the other company that we were working with. So our work at Mission was more of a high-level view. We were brought in with the goal of reducing the amount of forklifts in the factory, but also trying to improve the material handling in the plant. So Mission Rubber had kind of grown organically. They started out with a couple of injection presses, and as they were growing, they kind of stuck them wherever they saw fit as they had space. There was no real strategic high-level planning to optimize material flow. So as they were going to bring in even more machines, they kind of ran out of space. So our job was to rearrange the factory floor and introduce new material handling solutions to reduce the amount of forklifts needed to move material through the plant, and also to optimize material flow. So you can see here, there's a bit of a spaghetti flow in the plant where it should take approximately 40 feet to travel from the beginning of the process to out to the shipping through the injection press and assembly, but instead it takes over 1,400 feet because of the spaghetti flow in the plant. So our job was kind of to straighten that out. So at the end of the project, this was our final layout. You can see that we've managed to reduce a lot of the spaghetti flow through the plant. Some of the ways that we were able to do this was by introducing forklift exclusion zones in some of these key areas where the assembly lines and presses were. And as a result, we introduced water spiders that would take a lot of the localized material handling. And so through this, we were able to reduce the amount of forklifts needed to transport materials, but also straighten out a lot of that material flow. So as a result of the project, we were able to realize a 66% reduction. So we calculated that based on the distance, the required distance traveled for the straight flow, we would be able to reduce 2 out of 3 forklifts in the plant. Also, as Charles mentioned, we projected that they would save an estimated over $80,000 annually, which resulted in a 73% internal rate of return based on the initial cost of rearranging the plant. But it also allows for future growth and innovation. By straightening things out and getting the plant organized, it allows for future improvements such as laser-guided vehicles. You can't have that sort of improvements when you have a really messy plant and spaghetti flow. So that was our work at APICS Fellowship this summer. Thank you.